Hello friends, today we are going to have some of the examples on stress distribution in solids. In the last video you have seen Boussinesq theory for a point load acting at the ground surface. So today we will take one example. Let's say there is a point load Q of 100 kilonewton, which is acting at the ground surface or at ground level. Now if you want to find out the stress distribution at a point which is located at 2 meter from the ground level and on the axis of the loading. Also you want to find out at some point B, which has got x coordinate, y coordinate and z coordinate. So its x coordinate is 3 meter, y coordinate is 4 meter and z coordinate is 2 meter. So this is the point B. This is and the coordinate of A, x coordinate 0, y coordinate 0 and z coordinate is 2. So at these 2 points you want to find out the vertical stress sigma V at point A and B. This is the first part. And the second part is also find out the shear stress. Tau R due to a point load Q equal to 100 kilonewton, which is acting at ground level. So this is the problem. Now, as we know that here we can apply Boussinesq theory to calculate the number 1 vertical stress. Also we can apply Boussinesq theory to calculate the shear stress at both point A and B. So using this Boussinesq theory, you know that the vertical stress sigma z is given by a Boussinesq coefficient Kb multiplied by Q by Z square. And tau Rz, the shear, is going to be sigma z at that point multiplied by R by Z. So you can use these expressions, these equations in order to find out the vertical stress and the shear stress. Now what is Kb? Kb, as I have already explained in previous video, is the Boussinesq coefficient, and that's given as, all of you know that it is going to be 3 divided by 2 pi multiplied by 1 upon 1 plus r upon z whole square raised to power 5 pi. So now you see, if this is the z axis, this is the vertical axis, then the point A is lying, or if this is the vertical axis, the point A is lying on the axis of the loading, so just below this, and its coordinate is naturally x coordinate is 0, y coordinate is 0, only it has got z coordinate 2. So here z equal to 2 meter. So you can find out at A. So at point A, the value of sigma z, the vertical stress, must be equal to, now because R is 0, so KB for R equal to 0, because it is on the axis of loading, so the horizontal distance of point A from ZZ axis is 0, therefore R is 0. KB becomes 3 divided by 2 pi, or it is equal to 0.4775. So it becomes simple. The vertical stress will be 0.4775 for point A multiplied by 100, and Z is 2 meter, and therefore Z square become 4. So naturally you can calculate this value very easily. If you calculate it, 47.75 divided by 4 gives you 11.93 kilopascal or kilometer per meter square. This is the value of sigma z, the vertical stress at point A. Similarly, if you want to find out tau rz, the shear stress, this also you can find it out. Tau rz will be given by sigma z at A multiplied by r by z. Now r is already 0, so this becomes 0, and therefore the shear stress becomes 0. So here the shear stress is 0, and vertical stress is 11.93. Now at another point, at point B, you have been given the x coordinate and y coordinate. So look here, very simple to understand, that if this is the z axis, this is the x coordinate, this is the y coordinate, so point will be somewhere here, because x coordinate is 3 meter, y coordinate is 4 meter. So this is the y axis, this is the x axis. So this is 3, this is going to be 4, and z is going to be 2 meters. So point will be lying somewhere here. Therefore, from z axis, the horizontal distance of the point, you will have to find it out. So therefore, r is the distance from z axis, so that you can find it out as under root of x coordinate whole square plus y coordinate whole square. So 3 square plus 4 square. So this becomes 9 plus 16, this becomes 5 meter. So you have got the value of R, and therefore R by Z you can calculate it. So R by Z will be, Z is 2 meter, so R by Z becomes 2.5. So Z is 2 meter, for point B is 2, and R is going to be this square plus this square under root, so it becomes 9 plus 16, that is 25, so it becomes 5 meters. So 5 meter divided by 2 meter, R by Z becomes 2.5. Having got this R by Z value, I can now find out sigma Z, the vertical stress at point B. You can calculate it. Now, for that, you need to know the value of Kb. So Kb, as you know, this is the expression. So you can use this expression and find out the value of Kb. So Kb will be 3 divided by 2 pi, that is 0.4775, multiplied by 1 divided by 1 plus R by Z is 2.5, so it becomes 2.5 square raised to power 5. So this gives you the value of Kb. So having got this, I can calculate the value of Kb very easily. So let's calculate it. 1, this becomes 2.5 whole square, 5 by 2, that is to the power y, 2.5 equal to this multiplied by 0.4775, that gives you the value of Kb as 0.003 7. So the coefficient, you can find it out by simple way by using this expression. So this expression gives me the value. So I have got this. Now sigma b, I have already got the value of Kb, so I can write it 0.00337, and the value of Q is going to be 100 divided by Z square. Z is, so it becomes 4, 2 square. So if I calculate it, multiplied by this becomes 25. So if the value is vertical stress becomes 0.084 kilopascal. So the value sigma Z at A is 11.93 over here, and at B it becomes meter 0. So it decreases. So maximum value you are getting here, and at B the value is going to be quite less. Now The another is what is the value of shear stress. So we can calculate the value of shear stress tau rz. So tau rz can be computed very easily. Having got at point B the value of tau rz, shear stress at point B is going to be sigma z at B multiplied by R by Z. Now R by Z is already known to me, it is 2.5, and therefore I can compute it very, very easily. Yeah, so 0.084 multiplied by 2.5, that is the value of R by Z. So the tau Rz, you get it as 0.021 kilopascal. So here it was 0, the value of shear stress, and at the point B it has increased. Here the value is 0.021 kp, and here it was 0. This is the locus of tau Rz, and this is the locus of sigma. So you can calculate at any given point by using the Boussinesq theory, both vertical stress and the shear stress can be computed. Thank you very much.